Hello, everyone, and welcome to the first part. I mean, there are three rooms, three sessions running right now, but this is the first part in the Rigi Kabat room or session, and I'm happy to be the one leading this for today. My name is Olanrewaju Oyinbooke, and you get to know more about me soon. But today we will be looking at something very unique, and it could actually bring a lot of values into an organization. Is how do you consume data science models, which is built and deployed within Microsoft Fabric with Power Platform applications and solutions. And this is like Fusion plus Fabric. So it's going to be insightful because it's a new kind of not fully developed, but it's something that's a use case that's really interesting and could be explored. And I'll walk you through that. Once again, Olanrewaju Oyinbooke is my name. I was an ex-Microsoft employee. Currently, I'm operations automation and AI lead at Prime 8 Consulting. I'm MVP alumni as well. And if you want to learn more or connect with me, you can actually scan the barcode. And of course, I'm Microsoft Fabric Analytics Engineer certified. Agenda today is going to be brief because we have a demo to run through to show. It's going to be about introduction, how do we build and score your machine learning model. In case you see my eyes looking there, my second screen is there. How do you consume this model you have deployed with Power Apps? And of course, we should test it. Is it working? And have fun together. I love the introduction by Kim. Every time I listen to Kim, it's always refreshing. While we know the value and what Fabric is, it is also important to see how really connected it is to the business. We know we're in the era of AI, and your AI solution is as good as your data. So data professionals in this space are already embracing Microsoft Fabric because it's truly bring quick value to the business through AI solution. And we have several workloads on Fabric. We have the data visualization, we have the data engineer workload, we have the data science workload, we have all those workloads. It's no longer news for data professional or what these workloads are and how you can leverage them to bring value. But there's still a gap here. And the gap is how about citizen developers? How about business users who really don't have access to Fabric? Can they still enjoy the Microsoft ecosystem? Which is, applications are integratable, and there's just a lot for you to get from Microsoft investment in Microsoft technology. So the question is, how about these people? Don't forget, if you have any question, you can easily drop those questions. I have my second screen here, and I'm also checking. I will pay attention to your question in the chat. Right. So how about citizen developers? How can a data scientist on Fabric build a solution and make it available that a citizen developer can actually consume one way or the other? So that's the question. And if you're wondering, why citizen developers? We have over 33 million of them. That's monthly active users on Power Platform. Over 33 million. So they are actually quite a number. And we know what these Power Platform tools are. Power BI, the Power Apps, the Power Automate. It is now Copilot Studio, and we have the Power Pages. Developers are welcome in Power Platform. And so as a Power Platform developer, how can you use your tool to connect to Microsoft Fabric and then bring more value to the business? So that's the question. So the whole scenario that I have here today is going to be how to connect your Power Apps to Microsoft Fabric deploy machine learning model. And this is a very simple scenario that I built, a use case, which is shoe size prediction. So I built a simple app that can help you predict, actually shop for shoes. And right there, you can actually, in case you don't know your size, you can click on a button that, give me a few details. I'm going to tell you what your size is. Not perfect because I synthesize the data. Then I trained the machine learning model, which I'm going to show us how I did that. So the size might not accurately. The model as of now is about 73. The R square is 73% accuracy, which really can be fine-tuned, can be improved, but it's working, and that's what matters right now. So it's an interesting use case where, how can you, within Power Apps, how can you just click on button and you're assessing solution that is deployed on Microsoft Fabric and you are using it for yourself. So let's move on. I'm going to share my screen again, this time around my browser, so that I can show you everything that makes up this demo, and then we'll run through them. I won't be able to build from scratch, but definitely every step that I go through, I will show you everything. I will demo the solution itself. Right. I'm going to stop sharing screen for just a few seconds. I'm going to share my browser. Okay. This time around, a new browser should be up now, and what you will see right here is Fabric Lakehouse, and you could see I'm loading the data set that I synthesized about 100,000 records. I just used Copilot to, and I wrote some Python scripts, use some distributions, and then generate those data sets. But where we're going to is the component that make up this solution. First, we have a Power Apps application that I have right here, which I can actually reset. So by the way, don't worry, it's not a beautiful app. It just show two things. Assuming you have a lot of shoes here to buy and to review, and you are just interested, oh, I want to check my shoe size. So clicking on this button, check your shoe size. You can toggle with these details. And when you click on check now, you just did some countdown. That's going to give you solution. All right, so I'm gonna go back here with this guy. I'm gonna turn this guy off. All right. And also, I have this table where the predictions is being stored so that it can be also monitored. So the prediction is being stored right on this table. And I have my scoring script for my machine learning model. And I have the machine learning model notebook itself, that where it is being trained. Yep, and this is the data, is 100,000 records. Okay, so we're going to get started. So we have the data. I have this data, like I said, they're synthesized. We have for gender, for different age, for height, for weight, for size in UK and US, but I'm actually using UK size for the training. I can actually do the same thing. I use US size. And yep, we're good to go. So this is the sample data. Then let's go in and build a machine learning model. And I'm going to walk you through those steps right now. The first thing I did, since my data in itself is right in my lakehouse, all I have to do is to read the data using Spark and then convert it to data frame in Python. And that's what you see right here in the first set here. I'm reading it, and then I'm setting the seed so that anytime I run this experiment, it always give me the similar result, same result. Then this is my function to convert these to Pandas data frame, because there is Spark data frame. Pandas makes it just easy for me to work with Python because I want to train using Python. And so I have this. And the next step here is I need to explore my data, exploratory data analysis. I just want to understand what distribution, how are these shoe size, how does it spread across the different sizes? What's the distribution? And you can see here it is bimodal. It is bimodal because we have some data around size 6 and average, and then we have some around size 9, which is regular distribution that we see out there today in the industry. And then move on here. I moved on here to encode my gender, because gender is male and female, and right here actually need gender to be 0 and 1. Machines understand zeros and ones, and whenever you are training models like this, you need to convert one way or the other, encode your data back into zeros and ones, and that is when you feed them into the algorithm. Some algorithm can actually take in your data irrespective of the format it is, but the classical ones, actually in supervised machine learning, they require you to encode your categorical data into numbers so that it's easier to understand the relationship and train the algorithm to build the model. So what I'm also doing there is to further dive into the data. So I'm exploring using core correlation matrix just to see what is the strength of association between these variables. Not really relationship, because correlation is not causation. So because they are correlated does not mean one is causing the other. So it's wrong to use the word regression or relationship. It is association. What's the strength of these variables with each other? I know you might not be a data scientist, but on this is a mix of different professionals, probably data scientists, someone who is into low code, and you're wondering how do they also do their work. So this is just like a fusion data science power platform kind of workshop, and I'm going to just run through this quickly, but I'm just taking my time to explain so that you know what is happening here. It's an art. Data science is an art. So most of the time, if I'm doing this again for a different project, I'm not going to go through exactly each of this line of steps because those data differs. The business question I'm answering differs. So I might even do a lot of the tweaking at each stage of my exploration. So, but at least there is going to be data exploration. And after I'm done with that, I could see what relationship exists that could help me in training and building this algorithm. But one important thing about Fabric is it just is sufficient in itself to run an experiment at the same time, build your model and deploy the model. And you're going to see where those things actually happen. And this is the first stage. What I'm literally doing is importing the algorithm that I need and the libraries. Actually, I'm importing the libraries, and these are the libraries. One deep change here is importing MLflow. MLflow actually help you to try experiment. This thing is not cast in stone. You are trying to run an experiment. So it is an open library, open source library that help you monitor your data science experimentation process. So the moment I start it, it's going to log in every data, every information that I need about that experiment. Every time you train an algorithm, it's an experiment you are carrying out, and you are going to evaluate, oh, is it successful compared to previous model, like that. So the MLflow library is what actually helped me do that right here. And you see, I'm setting up an experiment, and I'm calling it shoe size regression. I'm also logging it. So you say don't auto log, but it's going to override the pre-configured auto logging behavior. So I'm logging it myself. I'm starting the experiment. I'm also ending the experiment. And what I'm doing here is opening up a connection that, go ahead and start. This time around, you are training a random forest regressor. And all I'm doing right here is I've splitted data into train test, and I'm literally logging the metrics after training. And then I'm making a prediction for Y test, and I'm printing, hey, if you are done, tell me what is the mean absolute error, which is one of the criteria or metrics for assessing how performing your machine learning model is, and also tell me the R square, which is basically the percentage contribution of all the independent variables in your model to what you are trying to predict. So just telling me that, hey, from the results which we're going to see soon, it's just telling me that, hey, this variables that we have, the height, the age, the gender, the weight, they are contributing this percentage to the value you are trying to predict, which is shoe size. So if by the way, if they are not sufficient, then that's a challenge. I might have to look for additional variables or use another algorithm, at least find something that is optimal. So because the experiment, the same thing that was done there is the same thing I'm doing right here. I'm running this one for linear regression. The previous one was from random forest algorithm. So linear regression still the same thing. 23 seconds is quite fast. So it's done. And the last one is XGBoost. I just tried 3 algorithms so that you can tell what it is, if one is better than the other. Similar steps, logging the details because it's already there, and put in the evaluation metrics, train the algorithm, and print out the result. And you can see from right here, these are the results for training and testing data set. R square means 72.7% of the variations of the things that is happening in the UK shoe size is being contributed by the variables that we have here. So at least, pretty impressive. And what I'm basically doing right here is, okay, all the algorithms that I've trained, let me bring all the 3 together and check and evaluate their metrics. And that's what I'm printing out right here. This first one is random forest classifier. The second is logistic regression. And the last one is XGBoost. This might be a bit technical for people who are quite into business. All that concerns you is, where is the solution? How can I use it? I'm just taking time because there's one thing here, especially how can you deploy and consume? That's the part that is most important, and I'm going to touch there. So I was just basically checking my data set here, including the metrics now on a table. I can compare all of them on a table. And obviously here, the logistic regression. Okay, I just want to zoom here. Yep, you can see the logistic regression is the most performing because it has right here, the R test is 73.17. So it is the most performing of this model. Right. Then it got to the time, this is exactly where I'm now storing and establishing this model. What we've done is experiment. And now I know that logistic regression is the most performing. So I want to use the MLflow transformer. Say, Now, all the variables that I'm using to test this, convert them to input column, and then give this model a name because you are storing them as model, and this is the version. So now it literally stores and create the model. And here I can apply it, but I'm going to show us how it's being applied. I have a sample here. But one other thing that we need to see is the scoring script. The scoring script. The scoring script is simple. It's just you import necessary library. Scoring script is now that the model has been deployed, how do you assess it? How do you call it? Because it's not like Azure AI where Azure Machine Learning Studio where you deploy and you have API endpoint where you can easily call those APIs, supply the data, and it returns value. But here, what is still available in Microsoft Fabric is running notebook via API. So if you can trigger your notebook via API, then you can create a notebook that can actually score a model and then access it via API. And the change here, first, I'm importing pandas as PD. That's just my library for managing data in a data table format. And right here is where the trick is. I'm setting the variable. I'm pre-configuring the variable that I will need as input into my machine learning model for it to give me the output. And what makes the difference to make it a variable is this is like normal notebook, but I've done something to this notebook. If you look right here, you see Spark Python, but it is a parameter. So it has been parameterized. So the value are there, but they are not just notebook. Anytime you access this notebook, it's able to receive variables. And these are the variables that I've set here. The prediction ID, the gender, the age, the weight, and all of these are the variables that they can receive. So back here, and what I'm doing after that is, taking all the variables and then let me log in here and download my model, which has been stored, and then provide this input into the model and give me the output. And what I'm also doing is I'm storing the output back into a table, and this is the table. So every time I access this, it's going to throw the output here. Let's give it a test and see. We have just 5 records here, but I'm going to come back here and decide this. Gender, male is 0, female is 1. I'm going to make this 1. Age, we could make this age 40 or 41. We'll say the record. Height, 5.6 inches. Height value could be 6.6. And weight could be 60. And all I have to do is run this. Now it's going to take a few seconds to start this notebook because it's connecting at the bottom right here. You can see at the bottom here, its query session status is on, but gray means it's still trying to start the connection, and it's running right now. Okay, so when that is done, back to my Power Apps, it's not that hard. I just build this screen and I had all this input right into my app, but where's the logic happening? It's inside my check now. Not just check now. When that check now happens, what I'm doing here is I'm literally making predictions. So I'm running a particular flow called make prediction. That is the flow. So how do I get access to this flow and what is happening in that flow? The flow is just 2 actions. One action, one trigger. Interesting. And right there, you're going to see the flow. I'm going to edit and you see the flow. While that is running, back here to my notebook, the session is ready. I'm going to run this. Shift and enter is running that. So this value now has been stored inside those variables as parameters and will be passed here. So here is just taking some steps. First, download the image of the model that we've built. So the models is like a black box, but at this point in time, it's really not black box. It's explainable. All the features are there. So it's downloading the artifact. Okay. After downloading it, I need this input to make predictions. Oh, you have given me the input. Awesome. Figuring everything out, put the input, and then make predictions. And after you're done making prediction, then store the result, append it to a table that we currently have. And that's what is being done. It's appending that right now. Once it's done, 35 seconds is done. When we go back here, we're going to see this new record. And we're going to see what has been predicted. I really do not need it to show me what the result is in the notebook. I need it to store it on the table. So we're going to have 6 records on the shoe data prediction table right there. And while that is loading, okay, we have 6 records. And the recent one is number 2. Yeah, that's this guy. Number 1 is at the top. 41, 6.6, 60. Say the shoe size is 6.1. And prediction ID is number 2. But let's come over here. In Power Apps, the flow I'm creating is simple. It's just this. And within this flow, I'm taking in values. Unique ID, the gender, the age, the height, and the weight. These are the things that I'm doing. And the reason why I had unique ID, even though I do not use unique ID in my model, is I need something to be able to tell me what the result. Every time I send a request, unique ID is being sent alongside, and I can tell what I can filter the result coming back based on that unique ID. And in my invoke an HTTP request, which is where the magic is happening, I literally have to use this API URL, which I will explain just a moment, right here. Good. They've made it possible that you can actually trigger a Fabric notebook if you understand this URL of the request. HTTP.fabric up to, HTTP.fabric up to this stage, workspace, is standard. And items is standard. Job instance up to, there are different type of job instance that you can run, but this one is to run notebook. This is also standard if you want to run the notebook. What is variable here is going to be your workspace ID and the notebook itself, the notebook ID. So how do you get the workspace ID? Come back here to the notebook you want to trigger. These are notebook. And right here on the bar, okay, right here on the bar, you're going to see the first item here, the first number here after groups is your workspace ID. And then the one here is your notebook ID, is unique to the notebook. Is unique to the notebook. So when you have these two items, you copy them from here, you plug them into the URL, and you're good to go. But that is not all. You see, after we've sort this side, then you need the body of the request. So there is a JSON schema, which is right here, that executes. And what this is doing is it's taking all the variables in and is declaring the type of value. So it also matters. So as you can see right here, I'm saying, hey, prediction value, prediction ID is going to be a string because I just need it as a string as my primary key on the table. Gender is int, even though gender is a number you're selecting male or female. But in my model, I have imputed to take in an integer value, so I cannot be passing a string. So how do I then undo gender? I did that in the Power Platform in my Power Apps. And you have the age as a value is float, height value is float, and weight value. It depends on the variable you use, the variable type when you are training your machine learning model. So you need to know that. And that's all. And back to my Power Apps. And back to my Power Apps where I'm actually doing this prediction. And right here, I am passing the data. When I'm calling make prediction, I'm also making sure I'm storing, let me open this more. I'm storing the last prediction ID to be this guy. I'm just using my unique ID is date. If I'm generating a random ID, there's potential of having the same value. And I don't want that. So the right time up to seconds and nanoseconds where that thing is happening is what I'm using as unique value. And right there is in text now. So that is what I'm using. Create a variable last prediction ID and just store that there. And when you're making prediction, the first thing is unique ID. So I'm just using the same text now as the unique ID. Then gender, if the value is male, then turn it to 0. If it is female, otherwise put it 1. Age value, age, the value that is in the age box, because the text box, input box rather, and height as well, the value there as well as weight. And because it takes some seconds to run, I think approximately 1 minute, 2 seconds, there are ways we're still exploring that where you don't need to use notebook. The moment the API endpoint is available in Fabric, it becomes easier where we're only calling the API and not the notebook. So calling the notebook, we want to start the notebook itself. Because if there's no current session, it can take a longer time. And within 1 minute, it's going to start, it's going to run, and it's going to generate a result. Right. And so what I'm doing right there here is to insert a timer that says, hey, wait for 1 minute and a few seconds. And after that, refresh your database because I have connected to a data source. 1, SharePoint, where I have the image and the description of the shoe. And second, the SQL server. Yep, the SQL server. So as you can see right here, I'm able to connect to Fabric Lakehouse. And what do you need? Once you go into add the data and you're looking for SQL server, the details that's going to request from you, they are right here in your Lakehouse, in your Fabric, and I can show you that right here. This is Fabric Lakehouse. And when you go to, okay, I'm opening a table right here. When you click on this guy called settings, and when you click on SQL Analytics endpoint, you will get the endpoint that you can connect to, which, I mean, not just in Fabric, you can connect to that within Microsoft SQL Server Studio. You can use Azure Data Studio, all those to endpoint for connecting to a database. You can use that. When you copy this string, that's exactly what I'm connecting to within Microsoft Power Apps. All right, and that way I'm just refreshing the data source, and the value here, where I'm getting the value is simple. I'm saying look up this shoe data prediction table, where prediction ID is equals to last prediction ID. Remember, I'm storing the value there, so it's comparing the equal value, and pick only predictions because that's what I need, not the entire record. Right, so let's start this. Let's give it a play, and then I'm going to reset first. When I reset, the value is really not there. It should clear. Okay, it doesn't clear, but you're just closing that. So let's give it values and see. This time around, I'm going to put this guy as female. Age, I'm going to say age is 56. Put that as float. So I just need to also include float there. Height, 14 here. I can have height in centimeter. So I can have 20. Weight in kg, say 72. And when I click on check now, right now it has triggered the button. It has refreshed data source and there's nothing here. But when I click on this guy, the timer, because I'm just using this timer, I can hide it, I can just run it, I can put an SVG tray, is loading right there while the timer is also calculating. And when it's done, it's going to show you the result. In a few seconds, we're going to see the result. But what's happening at the back end within here? This is my scoring script. When I go to view, under run, if I view all runs, you will see that at the back end is currently running. This guy failed 30 seconds ago. I just need to be sure if it's the one. 244. Yeah, that's the one. So one is running. No, that's the manual one that I'm currently running. So that's the notebook that is running right now. I'm going to stop this session. I'm sure there's a conflict session. There's a session running right now. So I'm going to stop this session, come back to, I'm just going to refresh. That's all, really. And come back here. But as of now, it should, when this guy is done with 10 seconds, it should load and try to show value. But obviously, there's not going to be any value there because there's nothing. The model did not run. So let's run this again. Age 56, 3. We can say height 20.2, weight 72.3. I think because I set it as float, so you can always configure how that is set to the nearest decimal number. So I'm going to click on check, and this time around it's going to also run and trigger the flow. Now that the flow is triggered, I have to, let me come back here to view, under run, come to view all runs. So you see right now is running, even though I'm triggering it in Power Apps. Right now it's triggering this notebook. The notebook is running, and 30 seconds into it, if I refresh now, I can see how many seconds into that. 29 seconds, almost done. And we're going to see the changes on the table. We have 6 record there, it's going to become 7. And here, nothing is showing yet. Oops, I also need to run this guy. This guy will take some. I can make the timer auto start, but I'm going to see how everything flows together. I think time is up now, but this is the end of the session on the demo. We're going to see the results, and I can also take questions. It will be nice. I see question here. Amazing session. I can't wait for it to directly be available in Fabric. Awesome. It will be nice if they also directly probably include refresh notebook and more Fabric centric action directly in Fabric. Yeah, there's semantic, there's opportunity to refresh notebook, but the issue is the API you are connecting to. Even if you refresh notebook, anytime there's a new record there, you must connect to an API that gets you back the question. So if I come back here and refresh, this should be done. Yeah, it's success. It just take 37 seconds and it's done. So right here within Power Apps, this in a few seconds now it's going to be done. Yep, it's saying, hey, after this record, your shoe size is 6.1. And when I come back here and load my lakehouse, you're going to see right there, there's now 7, there's going to be 7 records. And at the top, you're going to see the new one, which is exact value that we have input, female 56.3, that's the age. You're going to see 56.3, gender is 1, female 56.3. And this is the value, and this is the time it runs. I'm using this time as the ID, unique ID. All right, so I can take questions. It just show what is evolving, what is developing, and how you can actually still leverage Fabric resources within Power Apps. Thank you.